Let's continue our work with fractions. So in this section, we'll see how to compare fractions. So how can you tell if a fraction's bigger than another one or smaller? Well, one way is to draw their rectangles. So example 1, draw the rectangles for 2/3 and 4/7 and see which is smaller. Okay, so yeah, it's trying to draw kind of an accurate picture. If you make the rectangles the same size, yeah, so here's 2/3, 3 equal pieces, shade in 2. And yeah, here I tried to draw 7, yeah, roughly equal pieces, shade in 4. So yeah, it looks like 4/7 is smaller than 2/3 from the picture. Okay, so you can see that's a less shading. Yeah, so even though these numbers are bigger, so 4 is bigger than 2 and 7 is bigger than 3, this is still, it looks like a smaller number, a smaller fraction. But yeah, so this is just helping us understand, but yeah, maybe not a good way to compare fractions. Here's a better way. So this is an application of the LCD we looked at last time. Okay, so the least common denominator of 2/3 and 4/7 is 21. Okay, so yeah, the least common multiple of 3 and 7, you can check, it's 21. Okay, so if we write 2/3 with a 21 on the bottom, it's 14 over 21. And 4/7 is, so multiply by 3's, that's 12 over 21. Yeah, so now it's much easier to see which is bigger and which is smaller. So yeah, so this 12 over 21 is smaller than 14 over 21. So yeah, if you can see if you break this into, yeah, this isn't going to be visible, but each of these each of these 7ths into 3, and each of these 3's into 7ths. There's 2 more of these small pieces. Okay, so this is 14 21ths. This is 12 21ths. So yeah, so this is the smaller one. So yeah, so in terms of the original, yeah, so this is equal to this. This is equal to this. So this is smaller. So our picture was right, but this, yeah, this is a way to definitely see 4/7 is less than 2/3. And yeah, we're using the less than symbol. Okay, so that's the best method. So to compare 2 or more fractions in size, use the least common denominator to put them over a common denominator, and then you can see clearly. So example 2, yeah, maybe the question could be asked like this. Put 3/4, 2/5, and 1/2 in increasing order. Yeah, so increasing order means they should be increasing in size from left to right. So you want to start with the smallest, then the middle, then the biggest. Okay, so that's increasing order. All right, so first, the least common multiple of these three numbers is 20. So this is, if you look at the multiples of 4, the multiples of 5 and 2, so you're starting with the biggest. Yeah, there's a 4 here, no 4s there, no 8s, no 12s, no 16s. But they do have a 20 in common, and that's the smallest number. The smallest multiple they have in common, so that's the LCM. So 3/4, we need a 5, so hit this with 5s, that's 15 over 20. What do I have to multiply 5 by to get 20? I need 4, so hit it with 4s. And 2 times what is 20? 2 times 10. Okay, so we keep using this idea. I mean, the reason these are all equal is because 5 over 5 is really 1. So if you're multiplying by ones, then they're equal. Okay, so these are equivalent fractions. Okay, but when they're over the same denominator now, yeah, we can see the smallest is this guy. So we'll put that first. And then the middle, yeah, the 10 is before the 15, so 1/2 next. And the biggest is 3/4. All right, so this is the increasing order that we were looking for. And yeah, using the less than symbols, so yes, just to emphasize, so 2/5 is less than 1/2, that's less than 3/4. If the question was to put them in decreasing order, then that's just the other way around. So that's start with the biggest, that's greater than the middle, and that's greater than the smallest. So decreasing order means you decrease as you go to the right. Examples, more examples. Which is larger, 2/3 or 3/4? Okay, so we need to put them over 12. So hit this with 4s and this with 3s. So yeah, now we can see 9 over 12 is larger than 8 over 12. So 3/4 is larger than 2/3. Yeah, this is kind of like a word problem. So yeah, answering the word problem, this is the answer. Here's another increasing order one. How about this one? For this example, arrange the numbers. So here we have some mixed numbers. 1 3/5, 1 3/4, 1 6/7, and 11 over 12. And this time we want decreasing order. Okay, so that means start with the biggest, then the next, down to the smallest. Yeah, so the first thing, yeah, you can see this is definitely the smallest since these guys are bigger than 1. This is, again, 1 3/5 means 1 plus 3/5. 1 plus 3/4, 1 plus 6/7. So this guy, we can separate this guy out. This is the smallest, so this will come last. All right, so then we can compare these three. All right, and yeah, we can ignore those ones. So just subtract 1 from all 3 of these. So they'll still stay in the same order. Okay, we need the least common multiple of 5, 4, and 7. Yeah, so it turns out, yeah, it's just going to be the product of these. Let's see, in terms of the prime factorizations, yeah, 5 is just 5, 4 is 2 times 2, 7 is just 7, so the least common multiple has to contain 2 2s, 1 5, and 1 7. It's just the product, so 140 is the best you can do. All right, so 3/5. So you have to multiply 5 by 28 to get 140. So top and bottom of 28, you get 84/40. Here you need 5 times 7, 35s. And here we need 20s. All right, so again, over common denominator. So you see, so this is the biggest, and this is the middle, and this is the smallest. Okay, so yeah, it's 6/7 is bigger than 3/4 is bigger than 3/5. And then add back the ones, we get our mixed numbers in this order. And then put back in that smallest guy, so that's the final order. All right, so yeah, that's probably the most difficult one of these you could see. All right, so the main thing to remember is, yeah, when you're comparing fractions with different denominators, then find the least common denominator and put them over that LCD. All right. Okay, so we finally get to the last operation we need for fractions. So yeah, we've looked at multiplication, addition, and subtraction. So the last one is division. Yeah, maybe this is the, well, yeah, I think addition and subtraction are confusing. This can be confusing too. So first we'll take a look at the idea of reciprocals. So yeah, we'll use this to relate division to multiplication. All right, so what is a reciprocal? Yeah, you've probably seen this before. So to get a reciprocal, one way to think of it is just put a 1 over the number. All right, so the reciprocal of 3 is 1 over 3. All right, Isn't 1 over 3 the same as 3? No, so those are definitely two different numbers. Yeah, in terms of rectangles, 3 is like 3 wholes, three ones really. But 1/3 looks like this, so it's just, so if this whole rectangle is 1, then this is 1/3. Okay, so 3 is much bigger than 1/3. Yeah, on the number line, yeah, 3 is here, and 1/3 is, it's 1/3 of the way from 0 to 1. So 0, 1/3, 2/3, 2/3, 3/3 gets you to 1. All right, so I'm just emphasizing, yes, 3 and 1/3, very different numbers. But how are they related? Well, yes, if you multiply 3 times 1/3, okay, we saw how to multiply an integer by a fraction. Just put the integer over 1 to make it into a fraction. So 3 times 1/3 is 3 over 1 times 1 over 3. Okay, we remember how to multiply fractions, so straight across. So we just get 3 over 3, and that's equal to 1, right? And that works for any fractions or any reciprocal. So if you start with 7, then 7 times 1 over 7 is also going to be 1. So yeah, so we get to our, I guess, a better definition. So two numbers are reciprocal if their product is 1. Okay, so each number is the reciprocal of the other. You could say it like that. Okay, so we're kind of pairing up numbers. So yeah, so 1/3 is the reciprocal of 3, but you could also think of it, 3 is the reciprocal of 1/3. And yeah, we do that here. So find the reciprocals of 2, 1/3, and 4/5. Well, the reciprocal of 2 is 1 over 2, because 1 over 2 times 2 is equal to 1. Okay, so we're using this definition. The reciprocal of 1/3 is 3. We saw that already. 3 over 1 times 1 over 3 is 1. And the reciprocal of 4/5 is 5/4, because when you multiply those two numbers together, you get 20 over 20, and that's 1. So yeah, so this is a good definition of reciprocals. Again, two numbers are reciprocal if their product is 1. And yeah, you can sort of see, yeah, so the reciprocal of 4/5 is 5 over 4. So you can see what happened. So the reciprocal of a fraction a over b is just b over a. So you flip it upside down. Yeah, we don't want any zeros on the bottom, so here a and b had better be non-zero integers. All right, so how does the reciprocal help us understand division? Relating it to multiplication. Well, let's see this example. Example 4, compute 6 divided by 2 and 6 times 1/2. All right, so 6 divided by 2, well, 2 goes into 2 goes into sect3 times. So 6 divided by 2 is equal to 3. How about 6 times 1/2? That's 6 over 1 times 1 over 2. So that's multiplying straight across. That's 6 over 2. And this really means the same thing. It's this is 6 divided by 2. Or you could reduce this fraction, cancel 2's. It's 3 over 1. Either way, you're getting the same thing, 3. All right, so dividing by 2 is really the same as multiplying by 1/2. You're ending up at 3, and it works for any number. If there was a 26 here, so 26 divided by 2, and 26 times 1/2, you'll get the same thing, 13. All right, and this, so we can see, so dividing by a number is the same as multiplying by its reciprocal, and that's true in general. Okay, so any kind of division question, you can always change it into a multiplication question. Just use the reciprocal. So here, for example, 3, what's 3 divided by 1/4? Okay, so the reciprocal of 1/4 is 4, right? If you multiply these together, you get 1. Okay, so from our box, dividing by this number is the same as multiplying by its reciprocal. So 3 divided by 1/4 is equal to 3 times 4. So that's 12. Yeah, if the question was 3 times 1/4, then the answer would be 3 over 4. But yeah, it's a different operation here. This is division. Okay, so we have a kind of a intermediate step. So first change the division into a multiplication, and then it's the reciprocal of the fraction. So this is how you divide by any fraction. Just multiply by the reciprocal fraction. Yeah, maybe this is another way to see what's happening. Yeah, so 3 divided by 1/4. You can make this division into a fraction. Okay, so drawing a big fraction bar here. So this is 3 over 1/4. Okay, so 3 divided by 1/4. Then if you multiply top and bottom by 4, okay, we'll get 12 on the top. 1/4 times 4 is 1. So we're getting 12. So it's just another way to see the same thing. Dividing by a number is the same as multiplying by its reciprocal. If you're dividing by this number and then you multiply by the reciprocal top and bottom, you get a 1 on the bottom, so you're ending up with a multiplication of the reciprocal. So this is, you can make this into a proof. All right, so the main thing to remember is for a division, a over b divided by c over d. So you're dividing this fraction by this fraction. Keep the first fraction, change the division to a multiplication, and flip this guy over. All right, so a over b divided by c over d is equal to a over b times d over c. So two things changed, multiplication, and we Don't forget to flip this over. Keep, change, flip. So yeah, just remember those 3 words. All right, but yeah, I prefer this box. So dividing by a number is the same as multiplying by its reciprocal. All right. All right, so yeah, basic typical example, 2/3 divided by 3/5. Okay, keep the 2/3, change this to a multiplication, flip this over to 5/3. And now we're back to just a regular multiplication. So straight across, 2 times 5 is 10, 3 times 3 is 9, so 10/9. Okay, so yeah, so just for division, this is extra step, and then after that, it's just a regular multiplication. But yeah, here's a mistake that's easy to make. Yeah, like when we were looking at pre-canceling, so can't I cancel these 3's? I mean, I've got a 3 on the top and a 3 on the bottom, so they cancel, right? No, so um, that would be true if this was a multiplication, right? So if we were multiplying these two, yet then we could cancel those 3's. But you can't. There's no cancellation here when you have division. And yeah, you can see the reason. Really, those two 3's are on the same side. They're on the bottom. So yeah, these 3's don't cancel. So yeah, so just yeah, don't get confused. So that pre-canceling, canceling something on the top with something on the bottom, that only works when you're multiplying fractions together. Just because, yeah, this 3, it's really on the bottom. All right, 10/9. How about this one? 15 divided by 3/2. Okay, yeah, so 15, that's 15/1. Keep, change, flip. So it's 15/1 times 2/3. And then multiply straight across. That's 30/3. And yeah, so 3 goes into 30 10 times, or cancel 3's. And the answer is 10. Yeah, we also could have, we're in a multiplication, so we can look for pre-canceling here. Yeah, 15 is 3 times 5. So these 3's cancel. So that's another way to see 10. Yeah, I know some people don't like pre-canceling, but it really is easier if you can see the canceling before you do the multiplication. You just so you just end up with smaller numbers. Yeah, so here's a good example where pre-canceling saves a lot of work. But first, so starting with this division, yes, so keep, change, flip. So we have 8/15 times 21/16. All right, so if you multiply straight across now, it's going to be a bit of a headache, especially when you have to then try to simplify. All right, but first, I mean, yeah, you can see there's a big simplification possible here. Okay, so now we're multiplying, so now we can pre-cancel. So yeah, 16. So looking at this 8 and looking at this 16, I see that 16 is 2 times 8. So we get a nice cancellation there. Okay, and also breaking these down a bit. So yeah, 15 is 3 times 5. 21 is 3 times 7. So this 3 on top cancels with this 3 on the bottom. All right, so we're just left with 7 on the top and 5 times 2 on the bottom, so 7/10. All right, so yeah, if you multiply straight across here, what's that? 168 over something big down here, 240. So 168 over 240, then look for common factors. Okay, so this is the simplified answer, so 7/10, yeah. Okay, yeah, so we haven't worked that much with mixed numbers. So one thing you can always do with mixed numbers, and in fact here you really have to, if you're multiplying or dividing mixed numbers, then convert them into improper fractions first. And then once you have the improper fractions, then carry out the operation. So page 102. Okay, so division is multiplication by the reciprocal of the divisor. So the same boxes. All right, so here we have two mixed numbers. So we want 2 and 8/9 divided by 1 1/2. And the question says, yeah, express the result as a mixed number. All right, so we remember from the start of chapter 3 how to convert a mixed number into an improper fraction. So it's 2 times 9 is 18 plus the 8 is 26. All right, so this first one is 26 over 9. And then here 1 times 2 plus 1 is 3. So this is 3 over 2. All right, so an extra first step here is converting the mixed numbers to improper fractions. Okay, then keep, change, flip. We get this. And then multiply straight across. Yeah, I'm looking for pre-canceling, but there's nothing cancels. So yeah, so it's just 52 over 27. And as a mixed number, yeah, 27 goes into 52 one time, and remainder 25. So the answer is 1 and 25 over 27. So does that answer make sense? So this number is close to 2, right? If it was 1 and 27 over 27, that would be 2. So does this number fit into this number almost twice? Yeah, so 1 and 1/2 fits into 3 twice, and this is close to 3. All right, so this answer does make sense. It's always good to check you're in the right ballpark. Yeah, here's a nice word problem. How many books, each 1 3/4 inches thick, can fit on a 35-inch bookshelf? All right, so we're trying to fit this number into this number. All right, so yeah, fitting a number into another number. Yeah, we've seen that a few times. That's division. Okay, so we need 35 divided by this number. For example, yeah, if your books were 5 inches thick, maybe math books, then 35 divided by 5 would be 7, so you could fit 7 of those books. But for this question, we're dividing by 1 3/4. Okay, so 35 becomes 35 over 1, and we're dividing by, so this improper fraction, 1 times 4 plus 3 is 7, so 7 over 4. Keep, change, flip, and we get this. And yeah, pre-canceling, so 35 is 5 times 7, so 7's cancel, and you're left with just 5 and a 4 on top, and a 1 on the bottom, so 20. So 20 of these books can fit on this 35-inch bookshelf. And yeah, so that looks right. If there were 1-inch books, you could fit 35. If there were 2-inch books, you could fit 17. So yeah, 20. All right, so we have an application of mixed numbers and division. All right, so yeah, so just to review, yeah, I know it's confusing combining fractions, yeah, with these 4 operations, yeah, addition, subtraction, multiplication, and division. So just to review, so part A, so to add 3/5 and 1/2, yeah, there's no way to do it directly. You need a lowest, the least common denominator. Okay, so for adding and subtracting, you need the LCD. That's 10 here. All right, so then put them over the same denominator. These are unlike fractions, so make them into like fractions. Add the tops together. 11 over 10. Same thing here for subtracting. Now you have 6 minus 5, so 1 over 10 for the difference. All right, so that's how you add and subtract. Now for multiplication and division, you don't need an LCD. Okay, so we don't need to put the fractions over 10. When we're multiplying, it just goes straight across. Okay, so we don't have to write this as 6 over 10, 5 over 10. That would be, it wouldn't be wrong, but it's, you're working too hard. You just go straight across. So 3 over 5 times 1 over 2 is just 3 over 10. And for division, keep, change, flip. So it's 3 over 5 times 2 over 1. Okay, so dividing by a fraction is the same as multiplying by its reciprocal, and we get 6 over 5. Okay, so we only need the least the LCD when we're adding, subtracting, or comparing fractions. Okay, if you're just multiplying or dividing, you don't need an LCD. And yeah, we ended up with improper fractions here, and for these two, you can convert them into mixed numbers. Yeah, sometimes it's more useful just to leave them as fractions. So yeah, I usually just leave them as improper. But yeah, if it says in the question to convert them to mixed numbers, then yeah, you lose a point if you don't. All right, so one last section: mixed numbers and mixed units. Okay, so when multiplying mixed numbers or dividing, then yeah, you must convert them into improper fractions first. So here's another example. This is 2 1/3 times 3 1/4. Okay, so written with parentheses like this, that means multiplication. So multiplying these mixed numbers, can't we just do 2 times 3 is 6? 1/3 times 1/4 is 1/12. No, I'm afraid not. It doesn't work like that yet, really, because we're adding. So it's really 2 plus 1/3 and 3 plus 1/4. So if you're doing it like that, you really have to FOIL. You'd really be foiling. So yeah, much better to convert these to improper fractions first. 2 1/3 is 7 over 3. 3 1/4 is 13 over 4. Multiply straight across, that's 91 over 12. So that's a good answer. And yeah, if you want to convert it to a mixed number, then it's 12 into 91 goes 7 times remainder 7. And so this 7 is this 7, and this 7 is this 7, so it's 7 and 7/12 as a mixed number. All right, so for multiplying and dividing mixed numbers, then yeah, you must convert them to improper fractions first. But if you're adding or subtracting mixed numbers, yeah, you can convert them to improper fractions first, but you can also leave them mixed as mixed numbers. So both ways give you the correct answer. So how about this one? 2 1/3 plus 3 1/4. Yeah, so the same fractions. This time we're adding. Okay, so these are the improper fraction versions. Yeah, the LCD is 12, so hit this with 4s and this with 3s. So we're getting 28 over 12 plus 39 over 12. Okay, add the tops, we get 67. So that's 67 over 12. And if you want a mixed number, 12 goes into 67 5 times, that's 60. Remainder 7. All right, so as a mixed number, it's 5 and 7/12. All right, yeah, and if you go back and compare the original to the answer, then yeah, well, yeah, we can already see that 5, so it's 2 plus 3. Um, so yeah, so we can see there is a second solution, and this is easier. If you do it like this, yeah, don't forget that 2 and 1/3 means 2 plus 1/3. 3 and 1/4 means 3 plus 1/4. Yes, we're adding these numbers together. Addition is commutative and associative, so you can switch the order. So 2 plus 3 is 5. You can do that first. And then 1/3 plus 1/4, common denominator 12. You get 7/12. All right, so the point here is, yeah, if you're adding or subtracting mixed numbers, you can do the whole number parts and the fraction parts separately. Yeah, just one thing. If you end up with an improper fraction here, then you can you're going to get some extra whole number pieces. And if you're subtracting, sometimes you have to borrow a whole number. Yeah, so always converting them to improper fractions first. It can be more work, but it's really fairly simple. There's no carrying and borrowing to worry about. Let's see, in the book 103. So yeah, so here's another example. 2 1/2 plus 6 3/4. And yeah, this is a nice way to set it up. So write the numbers vertically. Okay, and you can see where, yeah, so to add these fraction pieces, we need a common denominator, which is 4. And then add the fractions and the whole numbers separately. So 2/4 plus 3/4 is 5/4. 2 plus 6 is 8. Yeah, so is that the mixed number 8 and 5/4? Yeah, so usually for a mixed number, the fraction part should be proper. So yeah, 5/4 is really 1 and 1/4. So you can carry a 1 out of the fraction piece into the whole number piece. All right, so it's really, so as a mixed number, it's really 9 and 1/4. All right, so this is, yeah, it's carrying, and yeah, the same thing, borrowing if you're subtracting. And so here's an example of yeah, if you want to subtract 3 2/5 from 7. All right, so again, writing it vertically. Here, subtracting 2/5 from 0, you can't do, but if you borrow a 1, so 1 is 5/5. Okay, then you get this, so borrowing 5/5. So 5/5 minus 2/5 is 3/5, and 6 minus 3 is 3. So the answer is 3 3/5. And yeah, so if you don't like that borrowing, yeah, you could just convert them to improper fractions first. So 7/1 minus 3 2/5. 3 2/5 is 17/5. We have 7/1. Common denominator is 5, so hit that with 5s, you get 35/5. 35 minus 17 is 18, and then that's the answer. 18/5 as a mixed number, it's the same, 3 3/5. And here's an even worse example. And for mixed units, it's the same idea. So how about feet and inches? So suppose maybe you had something that was 3 feet 5 inches long, and you're adding that to something 6 feet 8 inches long. So what's the total length? So add these two lengths together. Maybe you're measuring something in your apartment or in a house. Yeah, so just remember there are 12 inches in 1 foot. Again, we can, just like the fractions and the whole numbers, we can add it vertically, putting things are the same under each other. Okay, so here's 3 feet 5 inches and 6 feet 8 inches. All right, so if we add them, we get 13 inches and 9 feet. But inside the 13 inches, we have, there's a foot there. So we can carry a foot out of this column. We're left with 1 inch. So we get 10 feet and 1 inch. So any number of inches bigger than 12, you work out how many feet you have, and they carry into this column. Okay, so these mixed units here, we're mixing inches and feet, and it's the same kind of principle. Let's do a subtraction. Subtract 4 feet 7 inches from 8 feet 3 inches. So vertically, it's like this. Yeah, we're subtracting this, so this goes on the bottom, right? 7 from 3 doesn't work. So borrow 1 foot. Okay, so I'm going to borrow 1 foot here, make it 7 feet. And what does 1 foot turn into? 12 inches. So 12 plus 3 is 15. All right, so we're just rewriting the top line. So 8 feet 3 inches turns into 7 feet 15 inches. So it's the same length, but now we have more inches here, and we can subtract the 7. So 15 minus 7 is 8. And now 7 minus 4 is 3. All right, so the answer is 3 feet 8 inches. And yeah, so that's confusing. So just to double check, yeah, if you add the 4 feet 7 inches back on, yeah, you're getting 7 feet and 15 inches. That's 8 feet 3 inches. So you get back to the beginning. Just yeah, remember, you can always check a subtraction by adding it back on and checking you get the original number. All right, yeah, you could have done this question by converting everything into inches, but that you get some big numbers. But yeah, just keeping the inches and the feet separate, and then borrowing if you need to. Okay, maybe look at one more example. Yeah, so you could have, so these are mixed units, so minutes and hours, or seconds and minutes. So 60 minutes in an hour, 60 seconds in a minute. Yeah, let's see this example. Hugo and Hector go to separate movies that start at the same time. Hugo's movie is 2 hours 5 minutes long, while Hector's is 1 hour 43 minutes. All right, so Hector finishes first. How long will Hector have to wait after his movie is over for Hugo to come out? All right, so it's Hugo's movie is 2 hours and 5 minutes. Hector's is 1 hour and 43 minutes. Okay, so I hope you see that this is a subtraction question. So we're subtracting Hector's the length of Hector's movie from the length of Hugo's longer movie. So what's the difference? So that's how long Hector has to wait. All right, so we want to subtract 43 from 5, but again, 5 is too small, so borrow 1 hour. Okay, so make this a 1, and then bring over the 60 minutes, so we get 65 minutes. All right, so now we can subtract. So 65 minus 43 is 22 minutes. 1 from 1 is 0. So yeah, Hector has to wait 22 minutes. All right, yeah, you could have figured that out using common sense as well. So yeah, 43 minutes, so that's another 17 minutes to get to 2 hours, plus another 5 minutes after that. So 17 plus 5 is 22. Okay, but again, this I like this vertical method. Keep the hours and the minutes separate. If you're adding, you might have to carry. If you're subtracting, you might need to borrow. All right, so that's some more sections covered.